What we'll look at now are two different types of systems that are quite important within thermodynamic analysis, and those are the systems that we'll be looking at. First of all, we have closed systems, and these are sometimes also called fixed mass systems. And they're called that because mass cannot cross the boundaries of one of these systems. So, as an example, let's say we have a piston cylinder device, which is a very popular one that we'll use within thermodynamics. And if we have some stoppers here that are holding the piston at a given point, and let's put some weight on it, so that provides a load. And within our cylinder, let's imagine that we have a gas. Now, what we will often do is we will draw a boundary around our system. So in this case, the boundary would be along the walls of the cylinder. And our gas is inside. Now, we can have a couple of things. Another term that we will have here, we'll refer to that as being the boundary. And out here, everything outside of our boundary, we will refer to as being the surroundings. Now, with a closed system, you can have a couple of things crossing the boundary, and those are the two things that are within the first law of thermodynamics for a closed system. And if you recall, we talked about heat, so the capital Q, and work. Now, work can go either into or out of a certain system. In this case, what we will be doing is we'll be showing a schematic of putting work in, and we're going to do that with something that is referred to as being shaft work. So we're rotating a propeller in this case, which is inside of our system, and it would be heating up the gas on the inside. And in the process, what we are doing is we're doing work, and we denoted that with a capital W. So in a closed system, work and heat cross the system boundary mass cannot. And that's why we call it a fixed mass system. So that is referred to as being a closed system. The second type of system that we will look at is the open system. And this is a system whereby mass can cross the boundary of the system. So to draw a schematic of an open system, let's say we have some inlet, we have some device that we have not defined. So this might be a turbo machine, for example. Such as a turbine or a compressor or a pump or anything like that. Just like with the fixed mass system, we have the boundary. Here we're going to draw another boundary. However, this boundary is a little different because mass actually can cross that boundary. And we refer to that as being the control surface. And within the control surface, we sometimes refer to this as being the control volume. If you've taken a course in fluid mechanics, you have probably done control volume analysis by applying the momentum or the energy equation. Very similar concept here. So what we have is we can have mass crossing the boundaries. So let's say we have mass flowing in and mass flowing out. What we will do when we do our analysis, we always have to describe the conditions of the fluid coming into and leaving an open system. And quite often what that means is we will prescribe the temperature, the pressure, the temperature, and the velocity. And in this course, what I'll try to do is use a fancy V for the velocity. We'll be using a little v for this specific volume that we'll introduce in a few minutes. And on exiting, we have pressure 2, temperature 2, and velocity at 2. So that describes the fluid leaving. The other thing that we can have here, just like with the fixed mass system, we had heat and work flowing across the boundary. Well, here we can have heat and work flowing across the control surface. And what we would have, we will denote it as a Q, but we're going to put an over dot, a dot above the Q, and that denotes a rate. So the units of this, unlike for the fixed mass system where it was joules, here it will be joules per second because it's a rate, or sometimes we refer to that as being a watt. And at the same time, we can have work crossing the boundary, again, a capital W with an over dot, and the units joules per second or watts. So that is the open system, and that's another type of system that we will be applying and studying throughout this course. We'll look at both fixed mass or closed system, and we'll look at open systems. And both of those would have their own form of the first law of thermodynamics that we will be applying.